Hey guys, we're going to go through and do a little bit of homework help here for 7.4. Go through a handful of problems and try to make sure, if you're not understanding how to do them, maybe some options for how to interpret those problems. That's smaller, there we go. Alright, so to start out with this first part, when we're asking you to evaluate a logarithm without using a calculator, that doesn't mean you can't use a calculator at all. What it does mean is that we want to minimize the use of a calculator. At least we can't put the logarithm into the calculator itself. So let's take a look at question number 17 here real quick. And understand that what we're really being asked to do is figure out what exponent do you put on 8 to turn the 8 into 512. So our first guess is to just pick some exponents and kind of mess around with it. I mean, I know it's not 1. I know it's not, I'm going to have to move my picture. All right, I know it's not 1, and I know it's not 2. 8 squared, you know, is 64. Maybe 8 to, oh, clear this. Let's start over. Let's try 8 raised to the third. That's 512. Oh, hey, look at that. So the question is, what exponent do you put on 8 to produce a 512? The answer is 3. I kind of lucked into that, but you just keep trying. If it hadn't been 3, I'd try 4 and move on down the line. Okay? So that's the idea of this first part. Yeah, I used a calculator, but I didn't use it to do the logarithm. I still had to figure out that the answer was 3. Again, it's the exponent that is the solution to the logarithm. 20 through 27, we're just putting them in the calculator. If it says ln, you use the ln key. Log, you use the log key. We get down here to these problems. Let's look at 30 and 34 real quick. On number 30, okay, anytime you have this kind of a setup where you have the log base 30 sitting inside the exponent of the 30. So you got to remember, this whole log base 30 of 4 thing, it's in the exponent. And so when you mix exponentials with logarithms, if the bases match, they will cancel, leaving me with an answer of 4. Now in question number 34, the base 5 doesn't match the base 125. Well, I can turn 125 into a base 5 problem if I can figure out how to write it. So this will be log base 5 of, and I need 5 to be my base. So I've got to replace 125 with 5 and an exponent. So I grab my calculator. 5 to the second is only 25. If I do 5 raised to the third, I get 125. So that tells me I can write this as 5 to the third. That's the same as 125. Now because there was already an x, I'm going to go ahead and stick an x there as well. So here the log base 5 is going to cancel the base 5 and the exponent, and my answer will be 3x. Okay? So we've got to get the bases to match using exponential approximation, and then we can go from there. Finding the inverse on these problems, let's take a look at question number 39 and 44. First step is to switch x and y places. So number 39 would be x equals 0.4 raised to the y. Well, the y is in an exponential problem, and to get rid of an exponential, we must use a logarithm. So we're going to apply a log to both sides, log to both sides. But I have to use the correct base in order to get this to cancel over here. So I'm going to use a 0.4 base, because if I use a 0.4 base, then this log will cancel that 0.4, leaving me with y equals log base 0.4 of x. Okay, a little sloppy with the handwriting, I know. We're kind of writing in a fairly small space. I should really open up and do it off to the side, but let's go ahead and do the second one and go from there. So 44, x would equal 6 plus the log of y. Now you might say, Mr. Welch, why in the heck do you keep switching x and y places? Well, it's because we're finding an inverse, and the first step to finding an inverse is to switch x and y. Now I want to get rid of this logarithm, which means I need to do an exponential shift, but I don't like this 6 being here. So since I can move it, I'm going to go ahead and minus the 6 to start. That'll give me x minus 6 equals log of y. Now in class, I talked a lot about this idea of jacking up a house, lifting the house up to put a new foundation in. So we're going to lift this up into the exponent, And in the base of our exponent, we're going to go ahead and put the same base that our logarithm has. Well, this logarithm didn't have a base. Nothing was written down there. That implies that we're dealing with a base 10 problem, which means I'm going to use 10 as the base of my exponents. Over here, the log base 10 will cancel with the 10, and I'll get y equals 10 raised to the x minus 6. And there's our equation. So this is what you're being asked to work on, this idea of using inverses and that the relationship between exponentials and logarithms are inverses and they wipe each other out to help solve problems. Good luck. I hope that helps with some of the homework, and we'll see you in class.